Let's begin today's session. Today's session we are talking about kinetic energy and potential energy of a particle performing simple harmonic motion. So today's point of discussion is we wanted to find out what kinetic energy, what potential energy of a particle which performs simple harmonic motion. So that means we wanted to calculate kinetic energy of a particle which is vibrating, kinetic energy of a particle which is oscillating, or the kinetic energy and the potential energy of the particle which we can say that which is supposed to performing simple harmonic motion. So particle which is performing simple harmonic motion, the particle which is performing simple harmonic motion, like that we wanted to calculate such a particle which is performing kinetic energy of such a particle which is performing simple harmonic motion. So first of all, just try to find out what is a kinetic energy. So kinetic energy is due to, we know that kinetic energy, this kind of energy is due to, it is due to motion. If the object which is in a motion, then it will supposed to have certain velocity. For example, now let's say it is a rigid support. What it is? It is a rigid support. This is a frictionless table. This is stable, right? And on a table, we are going to attach a spring. One end of a spring is attached to this rigid support. One end of that particular spring is, this is a rigid support, right? And another end of this spring is attached to the block, which is now going to slide over this particular frictionless table, right? This is the frictionless, right? Now we are going to apply force over here. So as if I am going to apply force over here, so this is applied force, Fa. It is nothing but what it is? Applied force. So due to applied force, what is going to happen? That our block will going to move further. For example, as soon as we are going to move this particular block with the help of this applied force, what will be the next picture over there? Due to the elastic property. So for example, due to this force, this particular block is supposed to, this spring is get expand little further, right? And due to that applied force, this block changes from this particular position to this particular position it is supposed to move. Now, there, just because of which property? Property of the elasticity. Due to elasticity, what's supposed to happen? That block or that spring, not block, that spring will tries to regain its shape and size. Try to regain its shape and size. Try to regain its shape and size. So due to that reason, which reason I am talking about? Due to the elasticity, this spring will try to regain its shape. So original shape was like this, right? So this spring will try to just come again to this particular, we can say, the original position. So due to that reason, what is going to happen? Next picture of that particular spring will get. So this spring will going to, we can say that, compress due to certain force. Who is going to apply the force? The restoring energy which is stored by pulling this particular block. म्हणजे हा ब्लॉक आपण काय म्हणत, आपण मूव्ह केल्यामुळं याच्यामध्ये कोणती जरी एखादी एनर्जी स्टोर होणार, त्या एनर्जीला आपण काय म्हणूयात, आपण इलास्टिक एनर्जी. आणि ह्या इलास्टिक एनर्जी मुळे आपल्याला काय होणार आहे, ती जी स्प्रिंग आहे, ती स्प्रिंग ह्या ब्लॉकला काय करेल, बॅकवर्ड डायरेक्शन मध्ये मूव्ह करायचा प्रयत्न करेल. मग बॅकवर्ड डायरेक्शन मध्ये मूव्ह जर करायचा प्रयत्न जर त्या स्प्रिंगने जर केला तर काय होईल म्हणत, आपण ह्या डायरेक्शन मध्ये स्पेसिफिक फोर्स अप्लाय होईल. So there will be the application of force. So that force I am going to consider that is equals to. So what that F is nothing but we can say that restoring force. What it is? It is a restoring force. So due to this restoring force, there may be the possibility of that this block will move towards backward direction. So due to that movement, due to the application of the restoring force, what's supposed to happen? That block will supposed to move by certain displacement. For example, some very short displacement I am going to consider. So this was the initial position, and this is nothing but the future position due to the application of the restoring force. Restoring force मुळे तो ब्लॉक रिटर्न आला, आणि रिस्टोरिंग फोर्स मुळे तो जो ब्लॉक रिटर्न येत असेल तर किती डिस्प्लेसमेंट झाली, ही डिस्प्लेसमेंट काय म्हणतो आपण डीडब्ल्यू घेतो. आणि इथे अप्लाय केलेला फोर्स काय म्हणतो आपण स्मॉल एफ विल बी इज इक्वल टू, आपल्याला माहिती आहे आपण ऑलरेडी शिकलो, दॅट इज इक्वल टू मायनस के एक्स. आणि जर समजा इथे रिस्टोरिंग फोर्स मुळे जे वर्क डन घडणार आहे ते डीडब्ल्यू घेऊयात, आणि झालेले डिस्प्लेसमेंट काय घेऊयात आपण डीएक्स घेऊयात. So due to the what force? Due to the this particular restoring force, a smaller displacement I am talking. Definitely there will be the possibility of a higher or bigger displacement, but the situation is here that due to restoring force we are going to consider smaller displacement dx, and due to this displacement we have work done dw. So dw will be is equals to minus of f dx. Why minus I took? Because applied force will be in this direction and the displacement is which is in this opposite direction. So due to the applied force, due to we can say that applied force, how much is supposed to be work done over there? That is equal to dw. So dw is equal to, we can say that force into dx. So why I took a small f instead of capital? Because restoring force moves that particular block in this particular direction, but the displacement I am going to consider which is in a this direction. So that's the reason why minus f dx. So dw will be is equal to, what is f? F will be is equal to minus kx. So I am placing over there. So minus of, what is f? Minus of kx into dx. Okay, still if you have any doubt with this particular f, why I just choose capital small f instead of capital F? Because normally work will be is equal to force into displacement. So which force? Whatever the force due to which we have a displacement. So due to whom this particular block is moving backward direction? Due to restoring force. So that's the reason why I choose the force small f here instead of, we can say that capital F. So work done we got, that is equals to dw is equals to minus of kx. Why minus sign? Because we can say that displacement in a forward direction and the restoring force applies in a opposite direction. So that displacement I am talking about, that's the reason why I took a sign minus over there. As we got a equation, so what equation here it is? Here equation is work done will be is equals to, this work done will be is equals to minus that will become plus kx into dx. So what we are talking about, we are calculating potential energy, not a kinetic energy. First of all, just let's find out potential energy, right? So potential energy, right? So dw will be is equal to, so for a smaller displacement work done is a dw. If there is a again smaller next smaller displacement dx, again next smaller displacement dx, we wanted to calculate complete work done, so integrate both terms. So in order to get a complete work done, in order to get a we can say that 100% work done, we wanted to integrate above equation. इंटिग्रेशन का करायचंय? कारण की सगळ्या स्मॉलर डिस्प्लेसमेंट जर कन्सिडर जर केल्या, त्या सगळ्या स्मॉलर डिस्प्लेसमेंटला किती वर्क डन झालं, तर दॅट इज कॉल्ड एज अ कम्प्लीट वर्क डन. मग ते स्मॉलर वर्क डन कसं, कम्प्लीट वर्क डन कसं लिहिणार? डीडब्ल्यू प्लस डीडब्ल्यू प्लस डीडब्ल्यू प्लस डीडब्ल्यू. मग ऍडिशन प्रत्येक वेळेस युज करण्याच्या ऐवजी काय करणार? मॅथमॅटिकली दुसरं ऑपरेशन काय? इंटिग्रेशन. So I'm integrating on both sides. So integrating on both sides. So by integrating, what exactly I'll get? Integration of dw will be is equal to integration of k is a constant that will come outside into x dx, and we are quite aware of that integration of x raised to n with respect to x will be is equal to x raised to n plus 1 upon n plus 1. Now x will change from where to where. So if I say that dx, I am going to say that from x is equal to 0 to x is equal to x, right? This much of displacement I'll take, means x will be from 0 to x will be is equal to x. This much of displacement is supposed to occur. Then I can put the limit of this particular integration over here. Otherwise, no need to take a limit also. You can directly apply the formula. So instead of n, I have here 1, right? So instead of n, I'll place a 1. Instead of n, I'll place a 1. Instead of n, I'll place a 1. So what integration I'll get? Integration x raised to 1 with respect to x will be 1 plus 1, that is equals to 2. So x raised to 2, x square divided by 1 plus 1, that is equals to 2. So what is the integration? Integration of complete work done. So addition of all the work done, that means integration, right? So complete work done here will be is equals to w, that will be is equals to k, and integration of x raised to 1 with respect to x, integration of x raised to 1 with respect to x, that is equals to x square by 2. So this is the new form of that particular equation we got. So this energy or this work done is stored in the form of energy. What energy is? The energy that is nothing but a potential energy. See, this work done is stored in the form of potential energy. So that's the reason why I'm going to take work done will be is equals to potential energy will be is equals to 1 by 2 kx square. So we got a new equation of a potential energy that is equals to 1 by 2 kx square. Okay, I'll repeat for you again. We have a block. Why I took a block? Because block performs simple harmonic motion. Applied force is in a forward direction. Due to elastic property, we supposed to have a restoring force that is equals to F. And due to this restoring force, we have a work done that is equals to dW. So dW I consider over here that is equals to minus of F dx. But what do you mean by what exactly we have a force? So force will be equals to minus kx, because restoring force is directly proportional to minus x, right? So that's the reason why F is directly proportional to minus x. I took a proportionality constant, that is by replacing equal term, equal sign. So F will be equals to minus of kx, right? So F, I'm going to place the value of F over here. So work done will be is equals to minus of, in bracket, the value of F is equals to minus kx, and into that dx will be as it is. So same term here we took. So minus sign will get cancelled. So I'm not going to mention that minus sign over here. So k x dx is nothing but a work done. K x dx is nothing but a work done. So in order to get integration, why I use the integration term? Because if that block will move like this, by what manner? So for example, I'm not going to show the spring over here. If that block will from this place to next place, it will come. Say displacement for this much of by changing the position from this position to this position, say block moves, right? So again, it will not going to stop over here. Again, it can move from further. We can say that further position. पुढच्या पोझिशनवर तो ब्लॉक आला, आणखी किती डिस्प्लेसमेंट झाली, dx झाली, परत पुढच्या पोझिशनला आला, आणखी किती डिस्प्लेसमेंट झाली, dx झाली. मग टोटल डिस्प्लेसमेंट किती झाली तिथं आणि टोटल वर्क डन किती झालं हे. आता हा ब्लॉक रिटर्न का बरं येतो? स्प्रिंगमुळे. आणि स्प्रिंगच्या कोणत्या प्रॉपर्टीमुळे? इलास्टिसिटी प्रॉपर्टीमुळे. आणि इलास्टिसिटी प्रॉपर्टीमुळे कोणता फोर्स अप्लाय होणार आहे? दॅट इज इक्वल टू रिस्टोरिंग फोर्स, राइट? So due to restoring force, how much work done will be there? That's formula I just mentioned over here. मग आता इथे dx एवढ्या डिस्प्लेसमेंट साठी झालेलं वर्क डन dw, एवढ्या डिस्प्लेसमेंट साठी झालेलं वर्क डन dw, एवढ्या डिस्प्लेसमेंट साठी झालेलं वर्क डन dw. सगळं टोटल वर्क डन जर शोधायचं तर एका वर्क डन आहे आपल्याला, आणि एका असे किती वर्क डन, असे n नंबर ऑफ वर्क डन जर घडले तर आपल्याला काय करावं लागेल? वी नीड टू इंटिग्रेट. सो ऍज वी नीड टू इंटिग्रेट or what is another mathematical operation that we can have? That is nothing but addition of all the work. So what I am just going to do, we can add all the work, right? We can add all the work. Every time we need to add. So instead of addition, what mathematical operation we can do over here? That is nothing but integration. So by integrating on both sides, we got an integration of dw will be is equal to k into the value of k कॉन्स्टंट अँड एव्हरी टाइम ज्याच्या वेळेस कॉन्स्टंट टर्म असेल ती इंटिग्रेशनच्या बाहेर येते. मग इथं काय एक्स रेस टू काहीच नाही, म्हणजे काय एक्स रेस टू 1. तर एक्स रेस टू 1 dx, आणि एक्स रेस टू 1 dx हा कसा आला मी असं सांगितलं कारण की एक्स रेस टू n with respect to dx will be is equals to x raised to n plus 1 upon n plus 1 हा फॉर्म्युला आपण वापरला. मग nच्या ठिकाणी तर काय 1 आहे, मग x raised to 1 plus 1 upon 1 plus 1 1 plus 1 upon 1 plus 1 आणि x raised to 1 plus 1 म्हणजे काय x square divided by 1 plus 1 म्हणजे काय 2. मग x square by 2 काय रिइंटिग्रेशन आलं. मग नवीन फॉर्म्युला आपल्याला भेटला वर्क डन, टोटल वर्क डन. आता तो पर्टिक्युलर ब्लॉक जाऊन काय होणार आहे, तो ब्लॉक जाऊन रेस्ट पोझिशनला येणार आहे. म्हणजे असं म्हणूयात आपण ऑसिलेशन झाल्यानंतर याचं ऑसिलेशन झालं आणि त्याच्यानंतर जाऊन तो थांबला. म्हणजे टोटल एनर्जी कशाच्या फॉर्म मध्ये स्टोअर झाली, वर्क डनच्या फॉर्म मध्ये स्टोअर झाली. आणि ती वर्क डन कशाच्या फॉर्म मध्ये स्टोअर झालं, पोटेन्शियल एनर्जीच्या फॉर्म मध्ये स्टोअर झालं. म्हणून वर्क डन इक्वल टू मी काय घेतलं, पोटेन्शियल एनर्जी घेतली. म्हणून पोटेन्शियल एनर्जी विल बी इक्वल टू 1/2 kx². सो वी गॉट द फॉर्म्युला फॉर द पोटेन्शियल एनर्जी, that is equals to 1/2 kx². Now again try to find out the values of kinetic energy. So what kinetic energy is? Now kinetic energy due to, we know that it is due to motion. Kinetic energy is due to what? It is due to, we can say that, velocity. So kinetic energy, why kinetic energy our body is supposed to possess? Kinetic energy is possessed by the body is due to only motion. And if the object is in a motion, what things it's supposed to have? It may have a displacement, it may have a velocity, it may have a acceleration. So these physical quantities due to which we can say that if object is moving with a certain velocity, that means it is in a motion, right? So we will consider, in order to understand the kinetic energy, we knew that from the lower standard, even from the 9 or 8 standard, we already studied that kinetic energy will be equal to 1/2 mass of the body into velocity square. But if the particle performing simple harmonic motion, its velocity will be equal to 1/2 what? Not 1/2, sorry, not this formula. What we will be equal to plus minus omega square root of a square minus x square plus minus omega. You can either take a magnitude or otherwise you can take a, we can say that both sign of the velocity. I am just going to consider its positive value. So velocity will be like this. So kinetic energy will be equal to 1/2. Mass will be as it is. Now instead of v square, instead of v, I'll place this particular value. So what is v? That is omega square root of a square minus x square. So what is exactly? We only need to take a v. No, we need to take the square of the velocity. So take the square. So what it is there? So 1/2. Mass will be as it is. The square of this particular term is omega square. Square and square root will get cancelled. So what will remain in the bracket? That is a square minus x square, right? Now take a multiply 1/2 m inside. So what next step we will get? Kinetic energy will be equal to 1/2 m. 1/2 capital M, small m you can take. Capital M we already mentioned over there. So take a capital M. 1/2 m into omega square. 1/2 m into omega square in bracket. In bracket what will remain? A square minus x square. A square minus x square, right? So but we are already aware of that k is equal to m omega square. What it is, that is nothing but a restoring constant or the spring constant or the force constant. It can be considered as a spring constant. That depends on the material of the spring. Its value varies as the material of the spring values. Material of the spring varies, right? So k depends on the mass and the angular velocity, right? So kinetic energy, I'll place the value of m omega square as a k over here. So what kinetic energy I'll get? That is equal to 1/2 k in bracket a square minus x square. So this is the formula for the kinetic energy, that is performing by of a particle performing simple harmonic motion. So we got a new formula for the kinetic energy, that is equal to 1/2 k into a square minus x square. Now this is all about kinetic energy, potential energy. Now we wanted to find out whether the the total energy of the body is constant or not. So in order to find out that total energy of the body, which is constant means the value, total energy ची value constant राहते का नाही राहते, तर त्यासाठी आपल्याला टोटल एनर्जी काढावं लागेल. आणि आपल्याला लॉ ऑफ कन्झर्वेशन ऑफ एनर्जी S.H.M मध्ये फॉलो होतो की नाही, किंवा लॉ ऑफ कन्झर्वेशन ऑफ एनर्जी तो S.H.M मध्ये असलेला पार्टिकल फॉलो करतो की नाही ते आपल्याला बघायचं. सो बिफोर जस्ट गोइंग टू अंडरस्टँड वेदर दॅट पर्टिक्युलर पार्टिकल obeys laws of conservation of energy or not, for that purpose we need to calculate first total energy is equal to what. So let's find out the total energy. Now we got the value of kinetic energy and potential energy. So potential kinetic energy will be is equal to, what is kinetic energy? 1 by 2k in bracket, this formula here we have, that is a square minus x square. So now we wanted to calculate the total energy. What we wanted to find out? The formula for the total energy, and then we'll find out whether at all the position the kinetic energy and total energy, total energy of the body remains constant or not, right? म्हणजे प्रत्येक पोझिशनला कोणत्या प्रत्येक पोझिशनला म्हणजे पार्टिकल कुठून कुठे व्हायब्रेट होत आहे. मीन पोझिशन कडून काय नाही आपण पॉझिटिव्ह एक्स्ट्रीमला जातोय, पॉझिटिव्ह एक्स्ट्रीम कडून मीन जाईल, मीन कडून निगेटिव्ह एक्स्ट्रीमला जाईल, राईट. सो विदिन दिस थ्री पोझिशन्स whether the total energy of the body is constant or not. If it is a constant, then we can say that a particle performs simple harmonic motion. Follows what it follows? It follows law of conservation of energy, right? So total energy, the value of total energy, we knew that total energy will be is equals to kinetic energy plus potential energy, right? So what is the kinetic energy? Kinetic energy formula here we have 1 by 2k in bracket a square minus a square minus x square plus potential energy 1 by 2k x square. So what to do? Just simplify this bracket, multiply this 1 by 2k inside. So 1 by 2k a square minus 1 by 2k x square, right, plus this remaining 1 by 2k x term will be as it is, right. So what I just done over there, I just only multiply 1 by 2k inside the bracket. So 1 by 2k into a square, 1 by 2k a square, 1 by 2k into minus x square minus of 1 by 2k x square plus minus 1 by 2k x square and plus 1 by 2k x square, that will cancel. So what will remain there? Total energy. Total energy will be is equals to 1 by 2k a square. So we got the formula for the total energy. So total energy of a body performing, or total energy of a particle performing simple harmonic motion, its total energy will be equal to like this, right? Now we need to know law of conservation of energy. Is it followed by this particular particle or not? Law of conservation of energy. So what is the law of conservation of energy? Energy neither be created, energy nor be destroyed. We can't create energy, we can't destroy energy. We can convert one form of the energy into another form. For example, kinetic energy may get converted into potential energy, or potential energy may get converted into kinetic energy. That means the total energy of the system, or the total energy of the universe, is always a constant. Means total energy, the value of total energy will be is equal to k 1 by 2k square in all positions, whether it is a negative extreme, whether it is a positive extreme, or whether it is a mean position. All the energies total energy at all these positions will be remains constant. Let's find out. So at a mean position, at